In this video, we're going to be talking about doing cross-sections of three-dimensional objects and rotating two-dimensional objects to form three-dimensional objects and calculate certain things like volumes and different dimensions in those objects. Let's get started. First thing we'll talk about is a cross-section. A cross-section in any three-dimensional object is the two-dimensional shape that you get when you slice it. Take a look at this rectangular prism. If I were to slice a plane through the middle of it and put this part facing toward me and look at that straight on, what kind of shape is that going to be? Well, because this is a rectangular prism, this two-dimensional shape is simply going to be a rectangle. So a cross-section is simply what is that 2D shape that I get when I slice a 3D object. Let's look at some of these other shapes and see if you can come up with what they are. Why don't you pause the video and see if you can come up with the different shapes that you see in these images that I put up here. So look at all these pictures. I drew a couple of names of the shapes. We have rectangles. You can make a triangle if you cut the corner off of a cube. If you go down a cylinder, you can make a rectangle straight up and down, or along the parallel base, you're going to get a circle. Cones can get all sorts of things: circles, ellipses, which are ovals, parabolas, and hyperbolas, which we don't really get into in this class. You can slice a cone down. This is going to make a triangle. You can slice a pyramid, get a square or rectangle, depending on the type of pyramid you see here. Another rectangle. A sphere is just going to give you a bunch of circles, no matter how you slice it. And you can also do a pyramid down its side, and that shape, if you don't remember, is called a trapezoid. So lots of different types of cross sections. This is just a few examples for you, but what you mainly have to do is figure out how to solve problems involving cross sections. So let's look at that first example down below. Example 6, I'll kind of work out with you. Maybe you can try example 7. So example 6, a cylinder shown has a volume of 500 cubic centimeters and a height of 15 centimeters. What is the area and circumference of the cross section shown? So first, we have to recognize what type of shape that cross section is. And we're dealing with a circle here. Okay, a circle has a radius. And the question wants to know what is the area and circumference of that cross section. So area of a circle formula is pi r squared. Circumference is going to be 2 pi r. So we're going to use those formulas. We'll need the radius to be able to figure this out. So let's look at what we have. We have a volume of 500. And because it's a cylinder, I know that that volume formula is going to be pi r squared times the height. I also have a height of 15. So I'm going to write the formula down. V equals pi r squared times the height. And I'm going to plug in my V. My V is going to be 500 equals pi r squared. And my height is going to be 15. So I'll plug in 15 for H. Now I want to solve this for R. So I'm going to divide both sides by 15. $500 divided by 15 is 33.33, or about 33 1/3. I think 2 3s is enough. Cancel those 15s out, and you'll get 33.33 equals pi r squared. At that point, we want to divide by pi, and you'll get r squared is equal to 10.61. So I can solve for r by taking the square root of 10.61. And that'll give us about 3.257. So I'll round that up to 3.26. Now that I have my radius, I can plug it into both the pi r squared formula for the area and the 2 pi r formula for the circumference and figure out those values. Take a moment to pause the video and plug those in and see what you get. Okay, working those out, I got for the area of the circle, I got pi. I used the whole number that was in the calculator, so pi times the radius squared. And that gets me right back to 33.33. And if you recognize that number, that's the number we got before we solved for r, because, well, if you look at that, pi r squared, that is the base area. So we've already solved for that, but you get 33.33 when you plug it back in. The circumference is 2 pi r. If you plug in 3.26 or 25729, if you want to go out more decimal places, you get about 20.47 centimeters. And remember, your units for area is in square units, and for circumference is just in units. All right, read through question 7, pause the video, and try that one on your own. Question 7. A cube shown has a volume of 125 cubic centimeters. What is the area of the rectangular cross-section shown? You're going to need Pythagorean theorem for this one. So let's mark what we have. We have the cube that has a volume of 125 cubic centimeters. So I know that the volume being 125, and I know that the volume formula for a cube is going to be the side to the third power, side cubed. So I can actually solve that by setting s cubed equal to 125, and the side is going to be the cube root of 125, or you can do 125 and raise it to the third power, and that side is going to be, well, 125 to the third the 1/3 power is going to give you, it's going to give you 5. And remember, a cube is just a rectangular prism. So length times width times height, 5 times 5 times 5, that gets you right back to 125. So each of these is going to be 5, 5, 5, and we'll write 5 centimeters. And the question wants to know, what is the area of the rectangular cross section shown below? Well, I only have one section, and I have that 5 there, but this other dimension of that rectangle, we're going to need to actually calculate that using Pythagorean theorem. So I know that in any rectangle, it's going to be length times width. I know that this part is 5, the shorter part, but I can get the length of it by recognizing this right triangle here and calculating a squared plus b squared equals c squared. So if I call this c right here, I can say 5 squared plus 5 squared is equal to c squared. That's 25 plus 25, so that's going to be 50. And then remember, I can take the square root of 50 equals c, and the square root of 50 is going to be about 7, maybe a little bit more than 7, 7.07. So the area of the rectangular cross section is going to be 7.07 multiplied by 5. So if I take that, times it by 5, that'll give me about 35.355. So the area of that rectangular cross section is 35.355, or just 36. And that unit is going to be, since it's in cubic centimeters and we're talking about an area, square centimeters, 35.36 square centimeters. The next part of our video is going to be talking about rotations. You can take two-dimensional shapes, rotate them around some sort of axis, and get a three-dimensional object out of it, in which you can calculate things like volume and different dimensions of it. So you think about like a triangle. If you're to rotate a triangle about one of its sides, and you spin it around here, you can imagine that if I did a 360, well, that's going to form a cone. So any thing spinning is going to have something with a circular base in it. So just like a spinning triangle might form a cone, a spinning rectangle, since it has a flat side on both sides, will form a cylinder. And then you can get different types of shapes, like I can spin a trapezoid and get like a lampshade. Another common one here is going to be a circle. If I spin this around this line, I'm going to end up getting a sphere. A couple other different diagrams here to help you visualize. You can spin this right around here and get your cone. You can spin this rectangle and get your cylinder on the coordinate plane. So lots of different options here. Let's look at these three examples down below. So the first question is, what is the volume of the 3D figure formed from the rectangle shown below, rotated 360 degrees about the dotted line? So the first thing I have is, I got this 4x6 rectangle, and if I rotate that 360 degrees about the dotted line, think of that line being fixed, and this is gonna spin right around here, and it's gonna form a cylinder, okay? So our shape is gonna be cylinder, and we wanna know what is the volume of the cylinder. So the volume formula for a cylinder is pi r squared multiplied by the height. So in this problem here, this cylinder is tilted on its side. The height is actually gonna be 6. The radius, it looks like the whole side of this rectangle is 4, so the radius is gonna be 2. So I can actually just plug the 2 in and the 4 and the 6 in there and get your volume. So the volume is gonna be pi times 2 squared multiplied by 6. Calculate that out, see what you get. And the calculator says it's about 75.398, so I'll round that up to 75.4. And that, of course, is in inches. So since we're talking about volume, that's going to be in cubic inches. So the volume of the cylinder shown after rotating that rectangle is going to be 75.4 inches cubed. Yeah, look at number 9, try that one. What's the volume of the 3D figure formed from the triangle shown below, rotated 360 degrees about the dotted line? Pause the video, take a moment to try it on your own. Now, when you spin this around here, you're going to end up getting a cone. And the volume formula for the cone is going to be 1/3 pi r squared times height. So remember, it's very similar to a cylinder, except it's got a 1/3 out front. And the radius is actually going to be half this whole triangle's base. So 6 divided by 2 is going to be that radius there, which is helpful in this problem here, but I don't have the height. This 5 here is actually the slant height of the cone, the length sometimes it's called, and we're going to have to calculate that using Pythagorean theorem. So our height is going to be, let's see, we got h squared plus 3 squared equals 5 squared, and h squared plus 9 equals 25. Subtract the 9 from the 25, and you're going to get 25 minus 9 is 16. And h is going to be the square root of 16, which is going to give you 4. So that height is actually not 5, it's going to be 4 inches. So since my radius is 3 inches, my height we now know is 4 inches. I can plug those both into my volume formula. Plug them in, see what you get. All right, typing those into my calculator, 1 divided by 3 times pi times 3 squared times 4 is going to yield 37.699. So I'm going to round that up to 37.7. And our units are in inches, so the volume is going to be in inches cubed. All right, let's look at that last example, and then we're going to go move on with our practice problems. So example 10, take a minute to read through that and try it on your own. We'll go over it after you unpause it. All right, the problem says, with an area of 25 pi square inches, what a width, probably supposed to be a circle. So we'll go ahead and write circle there, got a little typo. A circle with an area of 25 pi square inches is rotated about the dotted line going through its center. What is the volume of the 3D figure formed? So we have this circle and we're spinning it about this dotted line. So if I rotate that, that's going to end up being a sphere. And for a sphere, we have to know the volume formula. So the volume is going to be 4 divided by 3, 4/3, pi r cubed. 4/3 pi r cubed. So we have to get the radius. And the radius of the sphere is the radius of that circle that's going around the center of it. So let's calculate that. The only thing I know is that a circle with an area of 25 pi square inches. So I know that that circle, whether it's this circle or that circle, it's going to have an area of 25 pi. And the area of a circle is going to be pi times the radius squared. So I'm going to set that equal to 25 pi, and I'm going to solve that for the radius. First thing, I'm going to cancel out the 2 pi's on both sides, and I have the radius squared is equal to 25. The next thing to solve for to get the radius is just take the square root of both sides, and the radius is going to be the square root of 25, which is going to be 5. Finally, I want to know the volume of that sphere. That 5, that radius of that circle is the radius of the sphere. So since my radius is 5, we'll plug that in. And the volume is going to be 4/3 pi times 5 to the third power. Throw that in your calculator, and you will get 523.598. So I'm going to round that up to 523.6. So my volume is about 523.6, and my units here are in inches. So since it's volume, it's going to be cubic inches, or inches cubed. And that does it for this video and this lesson. Hope this was helpful. Go ahead and try your practice problems and ask your teacher if you have any questions. Thanks for watching.